Alrighty, in this video we are going to be talking about related rates in terms of implicit differentiation. So we're going to do a couple examples of formulas that you should know by now, so like the area of a rectangle or the circumference of a circle, but we're going to take the derivative with respect to time, aka using implicit. But first, we are going to translate a couple of statements. So number one says the volume of a cylinder is increasing at a rate of 6 cubic feet per second. So since we're talking about volume, I'm going to say dV dt is equal to, since we're increasing, it's going to be 6. And then don't forget about your units, feet cubed per second. Number two says the depth of the water in a rectangular pool is decreasing at a rate of 2 inches per hour. Since we're talking about depth, we're talking about height, so I'm going to say that my derivative is going to be dHdt is equal to negative 2 inches per hour. Since we are decreasing, we want to make sure that we have a negative right here. Number three, at rush hour, the number of vehicles going through the SunPass toll booth is increasing at a rate of 85 vehicles per hour. Since we're talking about vehicles, I'm going to say dV dt is equal to 85 vehicles per hour. And then number four, air is escaping from a spherical balloon at a rate of 15 cubic centimeters per second. Since we are escaping, we know that this derivative is going to be negative. So we have dV dt, since air is escaping, aka volume is escaping, is equal to negative 15 centimeters cubed per second. All right, so for 5 through 14, what we're going to do is take the derivative with respect to time. These formulas are going to be very important for related rates. That's why today's video is called Introduction to Related Rates. So make sure that you know how to take the derivative using implicit differentiation with these formulas. And then knowing the formulas is going to help you, because then you don't have to waste like a couple of minutes deriving the formula. So number five, we're talking about the area of a rectangle. So we are going to say dA dt is equal to first times the derivative of the second plus second times the derivative of the first, of course, with respect to time. Number seven, the volume of a cube, so that's going to be dV dt is equal to 3s squared ds dt. Number nine, the area of a circle, so that's going to be dA dt is equal to 2 pi r dr dt. Number six, circumference of a circle, so that's going to be dc dt is equal to 2 pi dr dt. The lateral surface area of a cylinder, so that's going to be ds dt is equal to 2 pi, and then we have first times the derivative of the second plus second times the derivative of the first. Number 10, the perimeter of a square, dp dt is equal to 4 ds dt. Number 11, volume of a cylinder. Once again, we're going to have to use chain here. Not chain, product here. So dV dt is equal to pi first times the derivative of the second plus second times the derivative of the first. So that's going to be 2r dr dt. So since we have h, I'm going to say 2rh dr dt here. Number 12, volume of a cone. Essentially, it's going to be the same thing except as number 11, except we have a 1/3. So I'm just going to copy this and then just plop a 1/3 pi over 3. Ta-da. Crazy. A volume of a sphere, so that's going to be dV dt is equal to 4 pi r squared dr dt. And then number 14, side lengths of a triangle. We're going to be using lots of Pythag, and these are going to be the fun ones because we have 2x dx dt plus 2y dy dt is equal to 0. And then if I simplify it, you're just going to get x dx dt plus y dy dt is equal to 0. All right, so that was just a quick review of implicit differentiation with a couple of formulas that you should know by now. In the next video, we are going to talk about related rates and how some of these formulas connect with related rates.